Okay, so hello everyone. My name is Shreya Sharma and I'm a GSOC intern with the dashboard team. For the past 2 months, I've been working on the project reporting Ceph issues from the Ceph dashboard. The problem statement was that when a Ceph user encounters an issue, they gather all the relevant information and reach out to the developers using either the mailing list or they file an issue with the Ceph issue tracker. The problem with this approach is that out of the users facing this issue, some of them opt out of reporting it due to inconvenience, and out of the users that do report the issue, not all of them get a reply back. Well, as we can see in the funnel diagram, that already out of the users that faced an issue, most of them reached out, but out of them only most of them get a response back either from the developers or from the users. And even out of those, if the problem is genuine, they are asked to report it on the Ceph issue tracker. But again, some people opt out of doing that due to inconvenience. So at the end, out of the users that face the issue, we don't have a lot of issues reported. So this was the problem statement that we started it. Our solution to this was to provide the users an option to report the issues directly from the Ceph dashboard and the Ceph CLI. So this would widen the funnel as it would be convenient for users to report issues. So we expect more people to report issues now. This will also provide less hindrance while working since they don't have to collect the information from terminal and you go to Gmail or their preferred or send an email, file an issue tracker. They can simply report the issue from the CLI itself or the Ceph dashboard. This would also mean ultimately a better experience. And to report an issue, we take the bare minimum information required to report it. That is the project name, where they encountered the bug or the feature request they have for any project, the tracker type, which is a bug or a feature, the subject, and the description of the issue. Our initial project workflow decision was that when a user encounters an issue, he can either use a CLI command or a dashboard user interface. You would report issue in Ceph dashboard and the issue will ultimately be created in the Ceph issue tracker. So for this, our initial approach was to use the Python Redmine library. But after research, we found out that it is not available in CentOS. It's not a package there. So we decided to go for raw requests. But even the Ceph issue tracker is based on Redmine and is well documented. But even the curl calls that were given in the documentation did not work. When I tried using the curl calls, all I got was server error and I was not able to track down the problem. So Ernesto suggested me to use Wireshark. What we did was we sent a Python Redmine. We used this library to send a request to create an issue. And we tried to Wireshark to log the request, but Python Redmine library does not let us use the HTTP request and HTTPS request would be encrypted, so we were not able to use Wireshark either. But ultimately, we found some Python logging libraries that we used. They did not log the complete request, but we were able to see that it sent the project ID as a query parameter and not in the request body. So we were able to overcome this hurdle and now we're using Python raw requests to create an issue. Then a prerequisite for filing an issue is an account on the Ceph issue tracker. Ideally, it would be better if we do not ask the users to create an account on the Ceph issue tracker, but the main reason that we we verify the account is to avoid spamming. So we require the user to give Ceph issue tracker API key to avoid spamming and to authenticate the user when a request is sent. So they must have an account on the Ceph issue tracker. They can go to the My Account tab and get their API access key and store it on their machine, and they would then be able to create an issue using the Ceph tracker API key. Well, so we have two options to report issues, the Ceph CLI and the dashboard user interface. Using the Ceph CLI, we first set the API key using the command Ceph dashboard set Ceph tracker API key, and then giving the file name where the API key is stored. We can then create an issue using this command Ceph dashboard feedback create. We would then give project name, tracker type, subject, and description. This is an example, and we'll be having a look at the live demo soon. Then we have the dashboard user interface in which the user can go to settings and he would have an option to raise an issue. When he clicks on raise an issue, he'll be presented with this modal. So he has to select the project name from the list of drop-down project names. He will select the tracker name from the list of drop-down trackers, which would be bug and feature. He has to give the subject and the description. Also, we decided to go for a modal and not for the separate page because when the user reports an issue, he should be able to see the screen where he encountered it, so it's easier for him to collect the relevant description. And now let's have a look at the demo. So this is my terminal. I can set the Ceph tracker API key here. So I had my API key stored in a file called the redmine key. I have given the command Ceph dashboard set Ceph tracker API key redmine key, and my Ceph tracker API key has been updated. Now I can use it to create an issue. So this is the command Ceph dashboard feedback create. We'll then give the project name where they're encountering the issue. So I'll write file system here. Then the tracker type, I'll give it bug. We can give the subject title as live demo and the description as testing CLI. So I have given the command, and we get the message back that the issue was successfully created. The issue ID is 52056. Now, if we go to my page, we can see that this issue was created in Ceph file system. It has the title as live demo and the description as testing CLI. Now we can also use the Ceph dashboard to create an issue. So here we go to the raise an issue option. We can select the project as, let's say, dashboard, create a bug, the issue title as live demo, and description is test. So again, we get the message that the issue was successfully created and issue ID is 52057. So going back to this page, we can see that the issue was created in dashboard. The future scope of this project is the ability to attach images. If, let's say, a user is encountering a bug or an error that he did not expect in the terminal, so he should be able to attach it with the issue. We also want to give the user an option to give description from a file. Let's say the description is multi-liner, so it would be easier for the issuer to pass the file name as it would be easier for user to pass the file name as an argument to take the description for there, and we can also add deduplicacy to it using the Python what do you mean plugin, which is a plugin for redmine. So these are the future scopes of this project. This is all about my project. Thank you for attending, and I'm open to questions now.
Thanks a lot, Shreya. And yeah, to the other team leads, if you see some issues creating your project with a title demo, yeah, don't be alarmed. This is just a proof of concept. So, does anyone have any questions for Shreya? Suggestions?
This looks great. I'm really excited about this. I'm curious if there's a way, maybe even more about like a security issue, but for us to kind of have a pre-installed Redmine key that folks could use, so that they wouldn't need to create their own tracker account.
We can do that, but the main reason for this was to avoid spamming. So if we give the users a Redmine key, then like it's up for discussion. If that's what the community wants, we can do that. We can create a account that can be used by all the users to report the issue.
Yeah,
Might be worth a try.
we could provide an anonymous or a public API key. The thing is that as soon as it's leaked, probably we will start having the classical spam attacks that we had in the past. But maybe we can update that. I mean, on a regular basis just to avoid that. But definitely, I think it would be great for every user to be able to report this without and having to go through the process of creating an account, getting approval, and so on. So yeah.
Yeah, exactly. Like the Shreya, you mentioned in your presentation, I think that's a major step that often stops users from reporting things. You have to wait for the account creation to be approved and all that.
If
Yeah,
we
right.
are reporting from the dashboard or the CLI, then the chances of spamming is less, right? That someone is not going to intentionally spam.
Well, that's right, but if the key that is that we embed, you need to have that key embedded somewhere, right? For the dashboard to use it. If that key leaks, then we would basically need to disable it, and until everybody is upgraded. It would be just plain impossible to create an issue via the dashboard, which is probably worse than not having the functionality in the first place, because when the report the issue button doesn't work, the user who is already suffering from their cluster misbehaving would be even more pissed off than before. I think that maybe we could do something smart there and kind of require, find a way to verify that the issue is coming from the dashboard instance that is backed by a real cluster, like with some entropy there. But there's still like an issue that the key is still going to be embedded, and we still need to, have a way to secure it, because otherwise, eventually we would get spam, because people we get spam even in the downstream issue reporting systems. So people actually do register and go through the process of setting up the account, which is much more cumbersome than creating a Ceph tracker account, and we still get spam there. So need to be careful.
I wonder if obfuscating the key at some level would be sufficient. I mean, I would assume that most of these places where they're when they're spamming to Redmine, they're probably like searching for any Redmine instance that's open, or they're searching for Redmine keys. But if it's obfuscated such that they actually have to decipher and reverse engineer some code in Ceph specifically in order to spam to specifically the Ceph tracker, that might be sufficient to keep them away.
We could have,
that's what I meant.
Yeah, okay. Cool.
And coupled with perhaps, the fact that it wouldn't be just obfuscated, but also, in order to deobfuscate it, you actually need a working Ceph cluster, and not just a dummy dashboard instance or something like that. That would probably be enough.
Yep. I have two small comments. This looks great, but the dialogue where you actually submit the issue, the description should probably be a text box instead of just a single line, so you can actually have a verbose description. Yeah, that one. And then also, once it's successfully submitted, instead of just showing the issue number, it could just link to the tracker issue.
Yeah, I'll do both of these.
Cool.
I would add, it might be worth to add the source so that we know on our side how many users actually use this. So if we create another source at the back end and we populated, it'll be easier to filter out afterwards and see how useful it is, which hopefully it's very useful.
Yeah, that's a great idea. Might help with filtering spam if somebody wrote about to work against this as well.
Mhm.
Also,
I'm sorry. Can you please repeat that?
Sure.
I'm not clear what you meant. Yeah.
Yes. So at the back end of Redmine, we can create a unique source for this specific type of issue creation, which means it comes either from the CLI or the dashboard in an automated way. And then we can pre-populate it in your project. And when the issue is created, you can see in Redmine issue itself, the source field populated, and we can choose a name for it. I don't have a good idea now.
No, that sounds great. That's a great way to analyze how many users are actually using it, and we'll be able to get an idea about if we're getting like how this project turns out, if it's actually being used for good.
Mm-hmm. Yes, that'd be a great indication to see real data. So, yeah.
just adding to Yuri, if we are pre-populating the data, then since we are doing that from CLI, we can also in this project only integrate the system specific things of the user and maybe the code dump or some stuff related to debugging that might be helpful automatically for in a formatted way, read mine. And like Yeri said, that we can have a specific field for this project in Tracker, and maybe we can streamline the input better. That way, spamming could be avoided as well, and have the user define the describe the problem along with all the metadata that might be useful for a developer to investigate the bug. But yeah, it's a later scope thing, I think.
Yeah, we had this discussion in a stand-up about how this can be done, or I don't remember if it was a one-on-one mentor meet, but we had this discussion about how we can collect the metadata. And since I'm almost done with the front end and the CLI, once I clean up the code, I'll definitely do some research into how we can collect this data.
Awesome. Nice project. Congrats.
Thank you.
Just one question. Like I see the CLI command you are using. It's like called feedback, I think. But wouldn't it make more sense to use it as like create issue instead of feedback? Because what the user is actually doing is like creating the issue rather than giving a feedback.
Yeah, we can change it if that's we can discuss on it, and if that's what everyone wants, we can change it.
And just to reiterate, Sage also mentioned that in the comments, it would be great to add the affected version for that specific issue. This way, it makes it more informative for the developers to understand. So
I'll try adding that.
I have just another quick question, please. I put in the chat the link to the Python Redmine project. I'm just curious if this is the library that did not work well with CentOS for you?
Yeah, the problem with Python Redmine library is that it is not packaged for CentOS.
What CentOS version was that?
I'm not sure. Ernest, to do.
Yeah, I think we were looking for that in April 8, I think. So by the time that we checked that, we didn't see the package for April 8. Have you found that in 8, or are you running 9? Or
I think eventually I also use that, but I think I installed it with pip eventually. Yeah, so I didn't know it wasn't packed for that. Interesting. Thanks for mentioning that.
Yeah, that's a common issue that we are facing, but I mean, so far we still need to rely on packages. But let's see if in the future we can somehow get rid of it, or well, find a smarter way of installing fresher dependencies.
Mm-hmm.
I have a question, and well, it's not only for Sri, it's for everyone. Based on the reception from this feature, I was wondering if it would make sense to move part of the functionality to a separate module or something, because right now this would require the dashboard to be running, and I'm wondering if it would make sense for users not running the dashboard to still be able to report issues. So maybe having some of this functionality in a standalone module and the dashboard just consuming the CLI interface or something.
Yeah, I think that makes a lot of sense.
Okay, thanks. So
Yeah,
any
we'll
more?
make a separate module.
Yeah. Any more questions, suggestions for Shreya?
I just want to say thanks again. This is great.
Thanks a lot, Shreya.
Okay, so my name is Aryan, and I've been working with Ceph under Google Summer of Code for the past 3 months, and my project was visual regression testing of Ceph dashboard. So today we're going to discuss so this is what we're going to discuss today. We're going to discuss types of testing, and we're using in this what we're already using in the Ceph dashboard. And even after we have all these kind of testing, why do we need more tests? And yeah, so even if we have all these already existing testing, why do we need more tests? And the work and what exactly is visual regression testing, the workflow for it, and the different tools available for it, the criteria used to select the best tool for the Ceph dashboard, and we'll discuss the most popular tools and why some of them are not useful, and we'll discuss pixel by pixel bitmap matching, the algorithm, how it works, the techniques we use in that that three kind of tests we're using. Give me a second. I think my yeah. Yeah, so currently in the Ceph dashboard, we're using three kinds of testing. We're using, at the bottom, we're using unit testing, and it's really good if you want to test small functions and small components. And unit tests should focus only on the described purpose and shouldn't try to test other things in the same blocks. And we're using, on the second level, we're using integration testing, where we combine all these unit tests and see how they work together. The purpose is to expose faults in the interaction between the integrated units. And on the top level, we're using end-to-end testing, which is designed to mimic the behavior of the user when interacting with the application. Also, the test should verify that certain items are displayed as the user would see them when clicking through the UI, but this is where it sometimes falls behind. Yeah, so in Ceph dashboard, we already have this whole testing pyramid set up and running. So the question is, why do we need visual regression testing? The first thing is visual bugs are rendering issues, and rendering validation is not what functional testing tools are designed to catch. Functional testing measures functional behavior, and that's what it does. So what visual regression testing helps us is also it helps us in picking.
Sorry, Arjun. I'm afraid to interrupt, but I think at least my side, I'm not receiving your presentation. I reconnected, but it's still not there. So I'm not sure if I'm already mentioned that. Okay.
Is it
If you don't
visible?
mind. Yeah, not
I
yet.
can share again.
Yeah.
Okay. Is it visible now?
Yeah, it is now.
Okay, sorry for that. Yeah. Yeah, I'll begin from here. So in Ceph dashboard, we already have this whole testing pyramid that we see here. So the question is, why do we need visual regression testing? So the first thing is visual bugs are rendering issues, and rendering validation is not what functional testing tools are designed to catch. Functional testing measures functional behavior, and that's what it does. So visual regression testing also helps us in picking up CSS bugs, which we don't have any testing for. It also helps us in, it's also where sometimes users not able to see critical buttons, or they are in unclickable positions and stuff. The other thing, the other very useful feature of this kind of testing is it helps us in making very informed decisions on breaking changes, like when you're doing large refactoring or you're upgrading frameworks or libraries, like when you're moving from Bootstrap v4 or to Bootstrap v5 and stuff. So let's look at some of the examples here. In the first image, we can see that the login page is awkwardly positioned. This is a CSS bug, resulting in a user possibly not being able to access the elements. But this will pass all our testing pyramid, like all the tests, because the elements are still existing. And the second image is of the official Material UI website. Material UI is a very popular UI framework developed by Google. You see that the two buttons are awkwardly aligned, and you probably won't have issues clicking it, but it isn't a very good experience for the user, and it also hurts the reputation of the framework itself. This is an example of how visual regression testing can help understand how framework or library upgrades can affect the web page. Like in this, I tried to upgrade the Ceph dashboard Bootstrap version 4 to Bootstrap version 5, which caused an unintentional change. Like as you can see here, in the diffs, you can easily catch them. And with some of the visual testing tools, you can even see what went wrong in the diff itself. Like you can just click the diff mask and see that the form group class has been removed, which is exactly what will happen when you migrate to Bootstrap version 5. This is a breaking change. So it's really good for that. So to understand, now let's move ahead and understand what visual regression testing is. So to understand what visual regression testing is, we need to first understand what regression testing is. So regression testing is used to verify that any system changes do not interfere with the existing features and/or code structure. This is the reason regression testing is a part of almost every tool suite in software development. It is common for devs to change or add a section of code and having it unintentionally disrupt something that was previously working just fine. Visual regression testing applies the same logic, but confines testing to the visual aspects of the software, so only the visual aspects. In other words, it It checks that the code changes do not break any aspect of the code of the software's visual interface. A visual regression test also checks that the user will see what after any code changes have been executed by comparing screenshots taken before and after the code changes. This way, yeah. Okay, so now let's talk about how visual regression tests generally work. So the workflow for that usually looks like this. You initially run the tests, and since you already don't have any existing snapshots in your code base, you go here and you take new screenshots, and the screenshot will generate fast because and these state is called as baseline screenshots, and whatever snapshots you capture here will be considered baseline screenshots. Then to test, then you run the tests again when in your feature branch or something. Whenever you're making a change to the code base, you run the test again. It captures the screenshots, and now since you already have the baseline screenshots in place in your code base, you diff them. And when you diff them, they're either equal or they're not equal. And if they're equal, then it's fine. Your code looks fine. And then it doesn't have any visual regression, so it will pass. And if it doesn't, it will fail. So now let's talk about the different tools you can use for visual regression testing. There are plenty of tools you can find on the internet to implement these tests, and to select one tool for the Ceph dashboard, I had to come up with a robust criteria. So this is the criteria I came up with. So the criteria is it has to have like minimum manual effort, easy Cypress integration, because that's what we're using entirely for our end-to-end testing. It should have a very good open source support, and it should be able to ignore browser, platform, and anti-aliasing conflicts, which we'll discuss in detail in the next slides. It should also support responsive testing, because we do use some kind of responsive testing. Like we do have some responsive features and functions. It should also be able to very well handle dynamic data, because dashboard has a lot of moving parts, and to capture screenshots, moving screenshots is a big challenge. So the tools must have a really smart way to do that. It should also generate reports with comparisons, like this and a really good. We want the before screenshot, the baseline screenshot, the checkpoint screenshots, and the diffs in a report. We also need a very good CI/CD integration so that everyone can easily access the diffs and see what went wrong with the test. So we don't have a lot of tools that passed all these criteria, but so we'll just discuss some of the most popular tools, and then we'll discuss the tools that were the best and ticks all the boxes for us. The first in our list was Phantom CSS, which is also the first visual testing tool based on JavaScript. And this is where all the visual regression testing tools started to come up with. So what Phantom CSS does is it takes screenshots captured by Casper.js and compares them with baseline images using Resemble.js, and it generates those diffs with Phantom CSS, but it's really outdated. It was unmaintained since it has been unmaintained since 2017. It only works with it doesn't have a browser support. Like you can't see it actually in the browser. You can just see if the diffs failed or not in the headless mode. It doesn't have good test management tools and no reporting tools. Next on our list is Wraith, which is developed by British Broadcasting Council, BBC, built for performing visual diffs on responsive websites. It was a successor to the Phantom CSS. It also is really good on blogs and stuff, and it also allows authors to test various viewport widths, like very good with responsive. And it also has this really cool feature that it will ignore all these platform-specific anti-aliasing differences, which is the most part of the false positives. And since it was written by the BBC, it received quite a bit of publicity. Yeah. So these are the pros and cons. It has a really good anti-aliasing support. Like it won't have a lot of false positives. But even this was not really good for us because it wasn't able to handle the dynamic content well, and no reporting tools, and was only able to test full page screenshots, but we needed to test small components as well individually. The next on our list was Cypress Image Snapshot, which is the first intuitive approach that intuitive tool that we use. Since we already use end-to-end for our end-to-end test, we're already using Cypress, and it plugs in really well with our infrastructure. It is really fully open source, and it doesn't. And all of the before ones were open source as well. But the biggest problem was it was generating a lot of false positives. It wasn't able to ignore browser-specific anti-aliasing differences, and wasn't able to handle dynamic data well. It was also unmaintained since a long time. The Cypress dependencies have a lot of conflicts with our already existing Cypress dependencies. Also, the biggest reason was I talked about anti-aliasing offsets and all that. So let's talk about. So this is one of the most. These tools have like the same problem with them. The problem is that it all uses pixel matching, and one does not simply do bitmap comparison. It uses pixel by pixel matching, bitmap comparison. We'll understand why. Let's see how bitmap comparison actually works. Pixel by pixel bitmap comparison works. In bitmap comparison, bitmap of screen is captured at various points of a test run, and its pixels are compared to a baseline bitmap. In comparison stage, they iterate through each pixel pair and then check if the color hex codes are same. If the color codes are different, it raises a visual bug, and if they are same, it passes them. While these are very fast, they have a lot of problems. So the biggest problem was it was prone to they're prone to a lot of false positives. The biggest one of them was it wasn't able to handle a lot of dynamic data. When you have dynamic content that changes, like our Ceph dashboard, where you want to check in a dynamic environment, you want to check the layout is laid properly and the alignments and everything does not overlap and everything. The elements don't overlap. So pixel comparison tools can't test for these cases, and dynamic content is probably not the biggest downside of this pixel by pixel matching. The biggest was this. So this happens, as you can see in this picture, like you can see they look almost identical to human eye, but to pixel by pixel matching algorithms, they're not. It generates a lot of diffs. So this happens because of a lot of reasons. And these are not even dynamic images, like it's not even moving, it's static content. And this happens because of a lot of reasons, like font smoothing algorithms, image resizing, different graphic cards, and even rendering algorithms generate a lot of pixel differences. As a result, a tool that expects exact pixel matches between two images can always be filled with pixel differences. So to our rescue, we have AI for visual regression testing. And unlike pixel by pixel comparison, AI-powered automated visual regression tested tools do not need special environment that remains static to ensure accuracy, and hence have a uh, high degree of accuracy, and even with dynamic content, because the comparisons are based on relationships and not simply on pixels. So let's look at some of the AI-powered visual regression testing. First one is Percy, and in Percy is one of the most popular tools that is used a lot in these days in the industry. It is also known as visual regression. These tools are also known as visual regression testing as a service. What they use automated artificial intelligence to compare and learn over time, like if the diffs are failing or should the diffs fail or not. It has, so Percy has an SDK for Cypress and others. So it was really good for us. Like you can easily just plug it in and it works. You just have 3 methods. We'll see how the sample tests in the next slide. It has good Git integration. Some of the constraint was, since it wasn't open source, some of the constraint was it has 5,000 screenshots per month, and a screenshot is rendering of a page or component in an individual browser over different responsive widths, combinations, and everything. And if you want different browsers, it counts as one screenshot too. And it has 30 build. It only has 30-day build history, which is probably fine, but no, not really. So in our experience, it was able to very well handle the dynamic data and the moving parts of our dashboard. It has really intuitive dashboard, intuitive UI and very easy to understand. But it was still lagging behind in a lot of things that AppleTools was able to fill those gaps. So yeah, it is a bit more powerful than Percy. It has exhaustive documentation and easy CI/CD integration. But even it has some of the constraints. It only supports like 100 checkpoint screenshots per month. Checkpoint screenshots are taken after you take the baseline screenshots. But this is on the free plan, and for the Ceph dashboard, we're using an open source plan that AppleTools offered us. And in our experience, it was able to really handle the really well. It was really good with the dynamic content. It was able to generate ignore regions using code, and even with the GUI, we were able to add the ignore regions. It is very accurate. It had the minimum number of false positives, and it has really good Jenkins and GitHub integration that we're choosing. So this is one of the sample tests that it is merged actually in our Codebase. So it is really simple. You only have 3 methods in AppleTools. You have cy.eyesOpen and cy.checkWindow and then eyesClose. So if you're starting the AppleTools, you use eyesOpen, and to check window, use eyes.check. To check the content, you have eyes.check window, and it should be placed like where you want to capture the screenshot, like at which point of the test you want to capture screenshots, and you just close this, and you use cy.eyesClose when you're ending the test. And this is another test. I put this test because this is the test for dashboard component. And dashboard component has a lot of moving parts. It has a lot of charts which are constantly moving. So what we can do to mitigate that is just we only use a selector. We create an ignore region and we just pass in a CSS selector. And it's really simple to just add ignore regions. And this is the AppleTools config. Like you can see, you can give test concurrency. So and in free plan they support like 10 test concurrency, and you can just provide like an array of different browser widths and different browsers and different responsive widths, different viewport widths and orientation. You can even test it on mobile devices and everything. So we have a lot of dynamic content. I already talked about it, but in our Ceph dashboard, things are supposed to keep moving, and this is one of the dynamic element we have in our dashboard, canvas element, a chart element. So to stabilize these baseline screenshots and mitigate false positives, there are 2 methods that we can handle this. One is that we create an ignore region that that we're already using in the dashboard component, and you can create these ignore regions by either coding them, like you can just add a CSS selector, or you can just give the position where the ignore region should be, or you can go in the test runner and using GUI you can just mark the ignore region. And the next, the other method is by changing the match level. Now, by changing the match layer to layout, we can switch to different match levels within components and divs. Instead, it can check content, font, layout, color, and position of elements. And content, it can check and it is very similar to check, but it can also check for colors. It will ignore color changes. The last option is layout match level. With this match level, the eyes matching engine ignores differences in the actual content, text and graphics, color, and other style changes. This match level is most effective and used to validate pages with dynamic content. And right now in our code base, we're using tick matching, but even exact matching has worked really well for us. And I recommend trying out different match levels to see what you really need. In my experience, layout option is just used very good for when you have a blog page or a news site or something where you have different blogs coming every day and something. You can only check the layouts and stuff. So as we are reaching the end, let's discuss what visual testing is not. What visual testing is not is it does not verify the logic or functionality, and you can't replace it with functional tests. Functional tests are needed, and visual tests can't be used to check them. And they're also not typical fully automated test suite. You don't always want a passing or failing value. Sometimes when you make some changes to your code, make some changes, you'll have to go to the aptitude. You'll have to go to the session and manually check the diffs. So before this, let me demo you. So this is one of the pull requests that I made for this demo. In this, I have migrated the login component to Bootstrap version 5. But we can see that, wait, let me show you. In Bootstrap version 5, our a login page will look something like this, but all our tests are passing here, you can see. So this is really hard to catch using already existing solutions. So we have to use visual testing. And you can see visual testing was able to actually check the diffs easily. You can see it was able to find out the diffs. And to see what exactly went wrong, you can also use the root cause analysis, and you can select, yeah, you can click on the mask and see what all things are not there in the screenshots. So this works really well with our testing infrastructure and is able to catch the visual test really well. What's next for me? Oops. So next, I'm going to write more tests for the different dashboard components, and I'm gonna be writing contribute. You can help in that as well, and I'll be writing documentation for that, so you can documentation to write to write more tests, and you might have seen. And next, I'll also be working on the CI/CD pipeline. Integrate it well with the Jenkins pipeline. Right, so that's the end. If you have any questions, the open floor. Yeah, the open floor.
questions for Arjan? Suggestions?
I guess I'm kind of curious, not being aware of dashboard development so much. How often or what proportion of the bugs do you find tend to be these kinds of visual bugs versus more functional bugs?
Sorry, can you repeat the question?
In terms of like front-end development with the Ceph dashboard, do you have a sense of like how what proportion of bugs would be visual bugs as opposed to functional bugs?
There are a lot of bugs. Like one of the biggest thing that it can help in is detecting when you're upgrading new frameworks. Like since it's a JavaScript project, you have to keep moving and you have to upgrade it really fast. Like we're using Cypress version 4 and Cypress version 5, and now it's Cypress version 7, and also we're using Bootstrap version 4. And since we'll have to constantly upgrade our frameworks and libraries, we can see what changes are going to come up in ahead of time, and before merging it and see if something's going to break or not. It really helps in a lot of that as well.
Thanks, that makes sense.
Yeah.
I can see how it helps a ton with remembering new versions all the time and stopping those bugs from even being merged in the first place.
Yeah, the visual ones are really hard to catch. So I think this addition is going to help us a lot, especially currently we have tried not to migrate to the latest stuff like the latest Angular, the latest Bootstrap, UI, etc., just to avoid this kind of regressions. But with having this kind of safeguards, I think we can more safely, keep in updated with these libraries. Because every time that there's a new Twitter releases a new Bootstrap UI thing, we have to perform a massive refactoring, check everything that everything's okay. So yeah, that's really tricky. And also it sometimes works well with some devices, but then you get a report from someone running some strange browser, and that's very broken. So yeah, that's hopefully at least we will cover Firefox and Chrome with this, and that will be a starting point. But
cool.
Yeah,
one
of the best thing is we can see like different browsers and stuff. If someone says that the dashboard isn't working in Chrome, we can just open it in our Tools test runner and see how it looks like in their browser.
Awesome. So is this going to replace the existing kind of functional UI testing in some sense? Like there's like some of that exists in the end-to-end tests. Is that correct?
No, it won't be able to replace the functional tests at all. It is more visual tests are more complement to functional tests, because visual regression tests only test for the visual aspects of it and not the elements and everything, and even if they are clickable or not, and the different states of the elements and stuff. It's not gonna more of complement to the functional test.
I had to step out for a bit, so I may have missed this. But aren't we going to run into the limits imposed by the, by the cloud offering there, if we incorporate this into our regular Jenkins tests, which are, quite heavy and run quite often?
Yeah, so we did calculate the number of screenshots we'll be catching, like based on the number of pull requests we already receive on the dashboard. And Tools open source plans gives us 10,000 screenshots per month, which is pretty liberal. Like previously we thought it was 5,000 screenshots per month, but even then it was really good. So yeah, I don't think we'll be hitting that very often. Still seeing like we'll check this month as well. Like if I don't think so, will we? And even if you want to migrate to different, let's say you want to migrate to Percy from Applitools, it's just changing 2 lines of code in every test. So it's really easy to migrate to other tool as well. Yeah.
Yeah, let's see. We did a prior calculation, more or less the amount of screenshots that it would take, and it might work. We will probably need to tune that a bit, but let's see. In any case, well, I had some conversation with the Applitools team, and they, initially granted the open source plan. Let's check if they might be flexible in the future. I know that at least the Ansible Tower team, they are using Applitools as well for testing the UI. And they are using the open source plan. So, and I'm sure they are having quite a, high throughput and of PRs and so on. So, yeah, let's see. This is just a POC for the timing. So, but yeah, let's explore this. Okay, more questions? Okay, so thank you very much, Arjan. Really nice work. And we have now the last demo from the dashboard interns. So in this very case, Watt and Perry are going to talk about the Ceph manager and their experience trying to or caching that. So, Watt, Perry, are you ready for the demo or the presentation on the demo? Okay.
Can you hear me?
Yeah.
Okay.
All right. Hello, everyone. This is Wad Al-Kouri, and presenting with me Peter Diaz. So we're going to present what we have been exploring, analyzing, and developing in the last 4 months. We started early April, I believe so, with caching. And yeah, we're going to show you what we came up with, the ways we have done it, and how we did it. So why we have started this issue? First, we have been receiving feedbacks of some users. The module commands were taking too much time, up to seconds. The CPU were reaching the peak, and sometimes the module commands were unresponsive. And also, we could help the support team to debug the underperforming Ceph Manager API calls. That behaves like a black box without any further information. So how we did it? We have divided the work into two. I was working on the Python side and Perry was working on the C++ side. On the Python side, I have been exposing the API methods through the CLI, benchmarking the API methods, and multi-threading them. On the C++ side, what we did was tracing the manager model testing, injecting fake data, OSD map, PG maps, and so on. And we have worked on shared TTL cache from the C++ side because we have thought it would be better to have a shared caching than caching each module individual. And for serializing and serializing data, we have been using PyFormatter and JSON formatter. We have tested both and came up with different results. So how we expose the API method through the CLI with this command, we can expose, we can see all the commands. The -h is the help command, so we can see all the API methods, as you can see, the method and description about how to use it. So if we expose the OSD, the get method OSD map, we can receive this in a JSON format, as you can see, with manager API get OSD map. And now I'm going to talk about different types of benchmarks based on performance, level of performance, component level and system level benchmark. Component level is testing specific component which we have used, and system level benchmark evaluate the overall performance of running application. This can be divided into two categories based on composition. Synthetic benchmark evaluate a particular capability of a subsystem which undergoes a component level benchmark, and application benchmark measure the overall performance of the system. But we have to take in consider some rules to do the synthetic benchmark, which understand the composition of the benchmark, appreciate the factors constructing the results, and determine if the benchmark functions are typical of your workload and environment. So with this command, we can expose the benchmark. The API call will to benchmark an API method. Ceph manager API benchmark get OSD map, number of calls is the 1000, for example, and number of threads is the last parameter we pass. The OSD map is the data we are passing, the get is the API model, so on. Regarding this, we have seen some design flows. Well, as I said before, hard to debug the manager modules for developers. Ceph managers take quite long time. The queue take quite long time. The CPU reached the peak, and we have realized there is a missing of pagination to filter unnecessary data from the maps. So for further analysis and data, I will leave you with Perry to explain more what we have found.
Hey, so from now on, we're talking about the results that we got from caching the manager module. And if you don't mind having a headache or you're immune to it, you can look at the PR that you can see on top. And so basically, this is the structure that we currently have for the manager daemon. And basically, you can see that we have some maps on the left side in the manager. These are inside the cluster state, and we get the information from them from the manager get method. So basically, what we do is call mhr get OSD map, the get Python formats it with the Py formatter, and it converts it to a Py object and returns it to the manager module. So, for example, with OSD maps, there is a problem that is basically that we have two key value pairs that increase with the number of OSDs. And as you can see, one OSD looks more or less like this, and it's basically 3 kilobytes, and 1000 OSD can reach more or less 3 megabytes. So that's going to cause some problems. To solve this, we decided to go with a cache in the C++ side, so we can share the cache between every module, so we don't have to store every call in every module. And basically, we put the title cache there. And to do this, we had to solve some problems. The first one was that some manager modules were modifying the Py objects. As an example, there were some modules that deleted a value, and then another module tried to get that module. So since we are using Py objects and this object is shared between modules, if it's cached, it causes some signal errors. To solve this, we tried different solutions, and we went for the first one, which is the copy. Basically, because this is what we can do right now. And the other two, the immutable and copy on write, were a bit tricky, since in Python you have to traverse all the object to make it immutable or copy on write. So we first tried to benchmark the copy methods that we could gather. The first one was the copy. This comes with Python, and it was a bit slow in comparison with, for example, JSON and Pickle. JSON is a bit faster, but Pickle, since it's a binary serialization tool, it's much faster, as you can see. So this time we tried to see how much worse it would go from the default implementation that we had. to a pickle copy implementation, and it was 71% slower than the current implementation. Then we cached it, and it was 31% faster than the current implementation, which is a bit better, but not good enough. So what we thought about was changing the formatter to a JSON formatter. We went with the JSON formatter basically because we already have the implementation, and it was faster to implement in this case. So whenever you get a DOSD map, in this case with the JSON formatter, we serialize it with the formatter, and then we deserialize in the Python module. So we tried again the same benchmarks, and with the JSON formatter deserialization without caching, we got a result of 33% slower time than the default implementation. That's with 3,000 of this. And well, we cached after that, and we got a 56% faster implementation. Basically, you can see here the overall improvement with the caching and with JSON formatter. Also, we tried to implement a binary serialization into like another formatter that used binary serialization. Here you can see there are tons of them, and we went for message pack since it has support for CentOS and Fedora, and Pickle didn't have for CentOS, so we didn't go with that. At the end, we made it work with Ceph, but it didn't go fast enough. So we think that the problem was probably because when you stream data with message pack, there wasn't support for dynamic containers. So we had to make a quick fix for that, and at the end didn't work as fast. Also, it isn't actively maintained, so that's a problem. Okay, now I'm going to show you a demo of this. So basically, here we have 1,000 OSDs, as you can see. This 1,000 OSD come from an injection tool that we developed. And basically, I'll show you how it looks like to inject some load to the manager module, and without cache, and also with the JSON formatter. And so basically, we're going to run this. This will generate some load on the manager module. And as you can see, this takes a while to load. And yeah, they will finish now. And now we are going to try the same with the same load, but with the caching. Well, running. It's getting my effect, but it should work. Well, about future improvements, we think that we need some pagination because we are retrieving the whole OSD map, for example, instead of if we wanted to get, for example, 10 OSDs only, we have to get the 1,000 OSDs. So that brings some problems. Bringing some serialization and deserialization with JSON and another binary format can bring us to decouple the manager modules. So we wouldn't have to use more subinterpreters, basically. Also, we thought that it should be automated. The performance should be automated, and as an improvement to these formatters, we should bring binary serialization that we couldn't do successfully. Also, there are some deserializers for JSON that are more efficient that we haven't tried. As a conclusion, at first we saw that JSON formatter with a caching is 71% slower, but if we cache it with 3000 OSDs, we get a boost in with 56% faster than the PyFormatter. And moreover, we can decouple the modules if we use JSON formatter, for example, as we've seen some problems with sub-interpreters. And to finish, we think that the caching alleviates the heavy load problems, but it doesn't solve the entire problem. So that's basically it. If you have any questions.
I had a quick question. So the automated performance testing bit that you talked about, do you have any ideas or thoughts about, how you want to implement that or where you want to implement that?
Yeah, I want to implement that in the manager module basically, so it's easier to debug performance problems.
Mm-hmm. Yeah, we've talked about this, I think, in the past, have something run in the background which would, which tells us how the performance is over a period of time, and that's something we could also integrate with the telemetry performance channel in future. So the telemetry performance channel is essentially like your telemetry module. It has a performance channel that we are working on. So currently we are trying to capture more like OST specific and PG specific stats, etc. So if we have something that's running performance benchmarking in the manager in the background, maybe that's something we can incorporate.
Okay.
Do you have any ideas what kind of tests that you'd like to run?
We wrote more performance testing to the manager. That these were the ones that we needed, but there are some missing for different maps, and yeah, basically that we haven't tested all the cluster state maps that there are and the different parts of the modules. We only have tested with OSD maps and PG maps for the manager get method. So there is time to improve there.
Related, I was wondering if you looked as well at in terms of the caching, trying to reduce the fields needed to be cached for these structures. Like the PG map, for example, has tons and tons of information that I'm not sure the dashboard needs all of that all the time.
Sorry, I didn't hear you.
I guess the question is, have we thought about trying to reduce the amount of data in some of these structures, like the PG map or OSD map, have many different fields. Dashboard may not need to use all of them.
Yeah, I guess that in pagination we should have included to the reducing data that we send to the modules. So basically because, as you said, there are tons of information that we might not need.
Josh, we've seen a similar thing in the RGW CLS classes in the OSD where we need to filter based on a very small set of fields, and we end up decoding a much larger data structure and then re-encoding after we filter on those 12 different fields. It might be beneficial for us if we can restructure the way we think about these so that we really focus on specific fields that we need and figure out how to kind of avoid dealing with lots of extra data that's not useful for whatever our particular need is.
Yeah, we've done that in a kind of an ad hoc way with the PG map in the manager for other modules. We had added extra methods to get just particular pieces that they were concerned with. But yeah, it might be worth thinking about a more general approach.
I have a question. On one of your earlier slides, when you're talking about PyObjects, one of the problems was that they were modified. I'm wondering what instances, did you identify where they're actually being modified? They're being fetched? So I wonder if we could, in principle, eliminate those, then right.
Yeah, I don't remember exactly where they were, but I think it was in 2 modules, but I cannot give you the specific answer right now. There weren't a lot of them.
Yeah, the thing here is that you cannot prevent in the future this from happening. So that's the issue with Python, that you cannot really create immutable objects. It has to be a best effort from the developers not to, modify the structures, or otherwise the consequences will be catastrophic here.
Is there a way to poison them or mark them or something so that or mark them immutable? Is there a way to mark a PyObject immutable or something?
You could probably do something like overriding stuff like the methods that accessors and methods to detect when an object is modified.
Yeah, the thing is that as you are returning a nested structure, anything within that structure would be modified. So if you want to do that kind of thing, you need to traverse the whole structure, which is more or less the same penalty as you're paying when you are doing a deep copy, that you need to traverse the whole structure. It's deeply nested. So Perry was trying that using immutables and also copy and write approach. But in the end, I mean, if someone is accessing a list nested in 3 levels inside of a dictionary, you still need to grab that list and replace that with a frozen list or some kind of smart data structure to.
I'm just thinking if there was an optional mode that would do all this extra work and be probably super slow, but that would either detect modifications, then we could do that in all the testing, and then in production you would turn that off.
Yeah. The good thing of the JSON approach, and it can be replaced with a VSON or binary JSON or whatever, some other more compact interfaces, that we can decouple at last we can decouple the manager and the sub-interpreters thing. So we can have modules running outside the manager, maybe remotely. So that might be a first step towards that.
Yeah, okay.
Coming back to the previous question from Mark and Josh, one possibility, the API is not very fine-grained, so we are just returning these big chunks of data. So one possibility would be maybe to allow passing some XPath-like expressions, so you can filter things like the same as the JQ tool or the XPath expressions for XML, where you can define filter out fields like only return these fields, or that's not a simple thing, but it allows us to, just return the data that the consumer end is actually needing, instead of returning everything.
Yeah, I guess it might be a little tricky if you wanted to avoid the like JSON encoding overhead in the first place to apply that kind of filter.
Yeah. Let's say that you just want the first level in a nested dictionary, so you just return the first level of data. So maybe we can use some syntax just to say that, or maybe you just want to access some specific property in a dictionary. And if we can agree, we can use some existing language for that, and there are a couple of them, but we can use our custom if we just want to extend this behavior.
Yeah.
I think you mentioned that this is a TTL cache, which I assume stands for time to live, and I think you mentioned 10 seconds. That's what I've heard. But structures like OSD maps don't usually change that often. Does that mean that we do the work of recaching every 10 seconds? Or am I
Yeah.
misinterpreting the?
Well, you could set it to more seconds, but I did it with 10 seconds because usually it doesn't take that much longer for the benchmark.
Would it be easy to change the cache validation or whatever to instead just see if the epoch matches? And if so, reuse it, and if it doesn't, then generate. I'm not sure how the code is structured, but that might be
Yeah,
something to
because
try.
fundamentally these are versioned data structures. Each of them has a unique version, and sometimes there is a burst, so you could see, in 5 seconds you could see like 5 new versions, but under normal cluster operation, the same map would persist for could persist for hours, if not days. So this is throwing out the cached object every 10 seconds is definitely not ideal.
Well, Ilya, actually, the object won't be, the map won't be recalculated after 10 seconds, only if someone actually requests that. So the cache entry will become stale, and only if some module is requesting that data will be recalculated or reconstructed. But yeah, I agree that we might improve this further. Any more questions for Pere and Web? Nope. Okay. So thank you very much, folks, for yeah.
Thank you.
Okay.
Excellent presentation.
Thanks.
Great to see all the hard work that interns have been done in doing this work this summer. Excellent stuff. So the next topic is Jaeger tracing. This was brought up on the mailing list by Yuval. I'm not sure if Yuval is here. Deepak has also been working about that on this for the OC layer. But Yuval, do you want to introduce this more?
Sure, I can introduce that, but this is really in the scope of the RGW. This is what we've done so far. There's also Jaeger tracing in the scope of the OSD, and I guess Deepika can talk about that, and we need to sometime merge those two efforts, of course. So, I mean, in both cases, we use Jaeger tracing. There's a little bit of wrapping that we need to do around Jaeger tracing. It's not too much. At least in the RGW, we have two levels of disablement. One is at compile time, and this is for people that would build without Jaeger, or for systems that cannot support that from some reason. And the more interesting level is to disable at runtime. So the runtime disabling, inside Jaeger, they have something like a no-op tracer. So it has all the APIs that a regular tracer has, but it does nothing. So we allow via configuration parameter to change in runtime to enable or disable the switch between the no tracer and the real tracer. So there's no code change in those cases because they share the same APIs. I don't know exactly how runtime configuration changes are done on the OSD, but I think it should have the same mechanism there or similar one. Currently in the RGW, we started from tracing on the operations. So all the operation put object, delete object, get object, all these operations are going to create a trace, and then they can have one or more spans in them for some, which means if they're branching, then this could be supported inside. And that's going to be the basic implementation. We're going to add some tags, which is something that is supported in the in Jaeger. Those tags later on they're stored in Elasticsearch, so they could be used for searches. Like if you want to get all the traces for a certain bucket or a certain user or object that starts with something or whatever condition, then you can get that. A more interesting use case that we're going to have is in Jaeger there's an ability to serialize and deserialize the trace itself. So it could be picked up by another process or by the same process in a different thread or in a different place. The first use case we're going to have for this is in the case of multi-part upload. So in case of multi-part upload, you have like the init, and then you have each chunk, you have an object put, and then you have the complete. So we're going to use those serialization, deserializations, so that in the UI, it would look like just one big trace. All the different operations, although they can happen on different Redis gateways at different times and so on. Another step that we're probably going to use the serialize and deserialize function is passing the trace to Libradus and then sending that over to the OSD. And then you can have a trace that starts from the front end operation in the Redis gateway and trickles all the way down through Libradus to the OSD for all the operations. And even more interestingly, at least in the Redis gateway, we use lots of CLS. So there's like more complex code running on the OSD doing some extra work, and you can correlate those traces as well. The last piece that we're gonna hopefully use tracing for and get better understanding and debuggability of the system is with the multi-site syncing, which is something which is extremely difficult to debug today. Again, it would require serializing and deserializing the traces into the object or into the bucket index log, and then you would be able to figure out which object that was first handled by one RGW when it was fetched by an RGW in a different site or different zone, and this would give us better debuggability of this complex system. So that's like the main thing there. There is a different trajectory of development that is dealing with deployments. So the first step is going to be just documentation for a manual deployment. This is for just explaining how we expect the agents and the collectors and so on to be deployed, mainly pointing to the existing documentation, so there's not. Another type of deployment would be Ceph ADM-based one. And this is something that I think Deepika started, but it's still work in progress as far as I know. And the last option of deployment would be OpenShift based or Rook based, where that would be actually from Jaeger perspective, that would be the easiest, because Jaeger is actually geared toward Kubernetes or OpenShift deployments. So they already have an operator and everything. So that would be actually the easier part to do. That's another direction that we would need to progress in. And there were also thoughts, but this is like more advanced, about conditional tracing. Tracing would be heavy on the system, so it probably won't be turned on always by default. We want to be able to add a mechanism that would allow users in the field not only to disable and enable tracing as a whole, but also enable and disable tracing for specific operations or only for multi-site syncing and not for the operations, or only for CLS, only on the OSD, only on the RGW. So it kind of all kind of combinations of conditional tracing. This is pretty much in a nutshell the overall plan.
In addition to the conditional aspects, I think there's like some some level of sampling already in Jaeger. Is that sufficient for our purposes, or would we need to add some extra little sampling in Ceph itself?
I don't think so, because sampling is really saying, okay, from the entire tracing, we don't need all the traces. We're going to just sample 10%, and that's going to reduce the load. But I think that usually when you come to debug a system, then I mean, for example, if you want to use tracing in order to get some kind of estimates on the different latencies of the different steps in your process, so sampling would be sufficient and great solution in this case. But if you want to debug multi-site because you have problems, let's say one of the buckets is not syncing, and you want to debug multi-site, then sampling won't help you. You'll have to actually disable tracing for everything, so it won't stand in your way, and just enable tracing for bucket syncing, ideally for a specific bucket. And then there'll be low impact on the system, but you would get all the information that you need for debugging. So
yeah, that makes sense. You want
it's slightly
different approaches for different use cases.
Yes.
The reason I added it in CDM was just to bring a consensus between the development of RGW and OSD and how we can proceed forward, what is needed from OSD front and RGW, so that we have a complete development of tracing functionality in general, and what all features do we want to target as priority for Quincy maybe. In general, as Josh suggested, that there are sampling strategies. We can also have sampling strategies, from what I saw, that they would collect the spans locally, but they won't transmit it. And they would only transmit the ones that we choose to. And in case of failure, we also have those spans collected at the local daemon, but not transmitted, but still available for us to look into if needed, while also giving us a thorough picture of if there is some abnormality in the system. But yeah, that's again a scope for later and testing. From our OSD purpose, OSD perspective, we have added general traces for the key input-output functions that we have in OSD, and we also are targeting more of using the existing methods like marker points that we have in places where we generally want to record the matrix specific to that process, kind of adding that wrapper. And also we have contributions in Bluestore for tracing as well. So that's kind of the progress from OSD front. Of course, for encode and decode method, decellularizing and serializing from BRIDOS and RGW, and connecting the OSD and the RGW traces is the next thing that I would definitely like to do, or see somebody work would pick it up. Apart from it, any other developer-specific matrix that people would love to see, in a monitoring perspective, I would be welcome to have that feedback. And also, one thing is that these traces are not just local. If somebody has the traces, suppose a user has the traces, they can also convert those traces in JSON format, and those JSON format-based traces could be rendered anywhere as it is, for even a developer to take a look into what happened at with the system at that particular point of time. I added a blog link that might help somebody to get started with using tracing, and would love contributions there as well. Uh, Feel free to add any suggestions.
Yeah, I think from the syncing the two efforts, there is one small thing would be to have like one common wrapper and everything for the tracer instead of having one in RGW and one in under common. But that should be pretty easy because they're almost identical, the two wrappers. And for the serialized and deserialized, I think that one approach could be that you try to deserialize if there is something coming in the radius message, and use that as your parent span. And then if any client would serialize their span and send it over, because you always downstream from everybody, right? The OSD is always downstream from everybody. So if anyone is sending you a parent span, then you can deserialize it and use it as your parent span, and then in the UI, you would see the entire flow end to end. And if you don't get it, then well, maybe nobody sent it to you, maybe there's no need or whatever, and then you just start your own parent span and continue from there. And hopefully we would do that, of course, on our side as well in the RGW. But that could be any client, not necessarily RGW.
Yeah, you can imagine using the same thing looks that you'd want to have for multi-site multi-view also for, let's say, SFFS or RPD mirroring, debugging those systems too.
Yeah, makes sense.
It would be, I think we already have Zipkin-based traces there to begin with. If they are good enough, we can just start by porting some of them and asking the developers and experts for any other additional ones that are optimal. I think that's a low-hanging fruit.
Yeah, I'd imagine we could probably replace the existing like Zipkin Radius API with the same form kind of calls with acre tracing instead.
Yeah, and what you pass is just a binary object, so it doesn't really matter.
Yeah, exactly.
Also, you will, if we can do the disabling and enabling part all from a common perspective, or even like based on a component that we want to enable or disable tracing for specifically. I would like that, like
Yeah.
not have two different places to have support enabling, disabling.
So I don't know enough about how configuration works in RGW versus the OSD. So I'm not sure in the RGW we have access to OSD configuration parameters and vice versa. So that's maybe the question.
You can get them from the monitor, like you can ask the monitor for the configuration from like any entity's perspective. But I guess I would question in my mind would be, is this something that we want to control directly with like a Ceph configuration option, or some other kind of format of configuration?
I think it should be Ceph configuration. Just something that somebody goes in the command line, or I don't know if they have that in the dashboard, and just set it to true or false in runtime. I'll try again. I don't know a lot about how this configuration mechanism works, so I'll try to sync up with Deepika and see if we can have like a converged solution.
Sure. Yeah, that sounds good. Because we're talking about like things like the conditional enablements and conversely, like the sampling kind of approach, uh, it's more than just like an on-off option. So it probably needs more thought. In terms of, I think that what you described sounds like a great plan, and like the deployment aspect is especially key to making this usable and for both developers and for actual users, of course. I think those are kind of the first steps in my mind as well. Just getting the basics there. I think longer term it would be fantastic to expand this to include like background operations too, not just the IO path, so you can more easily debug and understand the behavior of the rest of the system as well. Like RGW's got lots of garbage collection and lifecycle things going on in the background. The OSD has plenty of like scrubbing and recovery and other things going on. Should be very helpful to get more observability into.
Yeah, once we have a good infrastructure in place, then it'd be like, anyone that writes a feature or fixes a bug and want to add tracing there because it helps them to do better work, then they can do that. So kind of be kind of scale out the work to other people that will just follow the examples that we said at the beginning.
Would be like the outlogging log additions.
Yeah, that'd be great.
I think even now people can do that, but yeah, we would need again the macros or disable Jaeger, or at least only in developer perspective we can use it. But yeah, if just working out the foundations would help people to use it in scale as well.
As another aspect that's missing, I guess, from the OSD side today is the integration with Crimson, since that's going to require a bit of modifications for how we use Jaeger to avoid locking and whatnot, and blocking. I'd imagine that we could probably keep the same interface, so that wouldn't affect this, like the general common flow for how you define the traces, but the implementation might need to be different for like Crimson internally.
So the way that we try to approach that on the RGW, because like we have like the front end has multiple threads and we're using coroutines there. The way that we approach that, hopefully that will be useful, is that the traces are just objects, so there's no locking or anything. But the tracer, which is what sends the tracers to the agent, is something that has a lock in it. It just has a lock when it does the sending at the end. So when you call finish on a span, it goes to the tracer and send the span over. So to avoid contention on those locks, so we cannot avoid the lock because unless we want to change the Jaeger code. But to avoid contention on the locks, what we do is that we define the tracer, instead of just being a global, it's a thread local global variable, which means that there'll be a lock taken, but there'll be no contention because there's only one thread that's going to use it at a time, and different threads that's going to use it, we're going to use a different client. So it'd be a little load on the system. So instead of one client per daemon connects to the agent, you're going to have, I don't know, 100 clients. But they shouldn't cost too much, and it would save on the locking. So maybe a similar approach could be taken with Crimson.
Yeah, that's a good idea. I think probably something similar could apply there. And yeah, I'm glad you've already looked into this a bit, because that's actually much simpler than I was thinking it would be.
We have new ideas to work on. Anything else specific, Jason? I think we can move to next topic then.
All right. Well, thanks, Deepika and Yuval. Very excited to see the tracing progress. I think it's going to be incredibly helpful for users and developers as well.
Thanks.
All right, so the next topic is telemetry crash reports. Yuri, do you want to introduce this one?
Let me share a link to the Etherpad. Yeah, so as some of you know, users who opt into telemetry sometimes they usually also opt into the crash channel that we have, and they're sending crash information about all the crashes that occurred in their clusters. And we have a crash dashboard. Maybe I'll share my screen. One moment. Can you see my screen?
Yeah.
Yes.
Yep.
Thanks. So here we can see the dashboard for all the crashes, and we have a search page that we can go over all sorts of specific searches according to versions and daemons, dates, and everything. So our goal here is to make those crashes trackable by developers and also by users. So whenever a user sees a crash in their cluster, they can go and search a tracker for the crash signature, and they'll be able to see the status of that crash. Maybe it's not even a bug. Maybe it is a real issue and there's a fix for it. So for that, we have a new telemetry crashes bot that tries to find a corresponding issue for each crash signature. So for example, let's see, yeah, we do have, maybe I'll say just a few words about the search page here. I guess most of you have already seen that, but just in case. So you can see the crash signature, which is a new signature that we created on the backend that groups more crash events together. You can see when's the first time we encountered that crash in telemetry, when's the last time, how many crashes in that.
Sorry to interrupt. Could you increase the font size a little bit? It's difficult to see.
Sure, yes, sorry. Is this better now?
Yeah, I can make out the numbers.
Yeah, okay. Cool. So the crash count corresponds to the time frame here. That's the total crash count, and that's just in time frame. So now we just chose new fingerprints in this time window. But if we change it, you can see that, for example, this signature has total number of 206 crash counts, but on the last 30 days, we saw that only 13 times. You can see the number of clusters that were affected by this crash and all the versions for the daemons that are reporting this crash. Yeah, and if you scroll sideways, you can also see the assert function and the assert condition if they exist. And here we have a signature. The original signature is reported by the user, so that's the client-side signature. And here we have the status of that signature. So we can click on that, and for the signature page, we have more detailed information. You can see the crash occurrence by version. You can see the the sanitized backtrace that helps to create the signature itself. By the way, if you click on each of these frames, you can see all the crashes that occurred that had this frame in their backtrace. So that can be very useful as well. In addition, you can see the graph for the daily occurrences. And of course, this is just for the last 2 years. You can change the time frame as well. You can see all the affected clusters, their size, all sorts of other information about them. You can also click on a specific cluster and see more graphs for that specific cluster, like a cluster X-ray. And here you can see an actual crash example where you have the exact maybe that's too small too, the exact crash dump here. But if we go back to the integration part with Redmine, we want for each one of these signatures a corresponding tracker issue. So, for example, this signature, the bot opened a new issue for it. It populated all of the affected versions so far, all of the signatures that were received from the client, the signature that we generated on the server side, and then it populated a description with a link to the dashboard and with all the other details. So, for example, the asserts, the sanitized backtrace, and a crash dump example. Now, the thing is that there are about 2,000 crash signatures. So we had a sort of test run, a few dozens of signatures that we opened tickets for, and I think all in all it went pretty well, and we want to know if we can go ahead and open the rest of the issues or decide on a cadence that we want to open issues every week. Josh also had an idea, because most of the signatures eventually are going to be classified as Rados or boost or manager issues, that since we have a crash queue and a crash triage queries now, we can just go ahead and open all of these issues and just work on them whenever, yeah. I just want to give another example here. So the bot will not always just open a new issue. It scans all of Tracker for the crash signatures. So here, for example, the bot found a bug that was already resolved that had the crash signature populated somewhere in the ticket. But you can see that the affected versions was 14.2.4, and there are no backports here. But if there were backports, we would go ahead and take their target versions as well. So we encountered new crash events in telemetry that were of a newer version than the one that was fixed. For example, you can see the 15 version here. So since that issue was classified as resolved, it means that it was a real Ceph bug. So we decided to open a new issue and to relate that to the closed one. This means that in case you see on Tracker issues that are not Ceph bugs, please use other status to close it other than resolve or need more information. So you can either use closed, not a bug, rejected, won't fix, a status that indicates that we don't actually need to provide a fix for that. So this is one thing. And the other is when you mark an issue as a duplicate issue, Tracker will let you do that without changing its status. So you can say that this issue duplicates a different issue, but the status will still stay as a new status. So please make sure you're also changing the status as well to a duplicate, and that the original has a status either than duplicate. So again, either it's open or it's closed, but not a duplicate status. Oh yeah, and another thing that I encountered was in case there are several issues that are marked as a duplicate to an original issue, please make sure that they all point to the original and not in a chain, like in a list, a duplicate to a duplicate to a duplicate to an original. That makes life easier, I guess, for everyone. Are there any questions so far, or what do you think of the idea of just go ahead and opening all those issues?
I wonder if we should find a brave lead who is willing to devote some time to do triage and then open like all the issues for like that one project. Maybe that would make sense.
I guess my thinking there was that it's the same amount of work for triage, regardless of whether the issues are open or not. So we might as well open them up, and if someone runs into the same bug, they can find it in the tracker.
Yeah, I guess. Yeah.
My other question was, does the bug queue exclude these tickets? Because I saw that on the crash queue, we are looking in the filters, we are relying on the source, but I'm not sure that here we will, I mean, we're not.
Change it to ignore the source
Mm-hmm.
from the crashes so that they're distinct lists.
Yeah,
Mm-hmm.
could exclude, I guess. I'm not sure if that's what we want or not. We can always add that if we're doing a scrub and we want to ignore crashes, we can add it manually, maybe. I don't know. I'm not sure if they should be distinct or overlapping, I guess.
I guess in the long term, we'd want them to be overlapping because at that point, we're just kind of looking at all the new incoming bugs. But in the during the import phase, maybe we want to maybe treat them distinctly if you don't want to just go through all of the